What's up, everyone? So, in the last video, we talked about the Gauss representation of the gamma function. In this video, we will talk about the Euler representation of the gamma function, which you see right in front of you. So, Euler says the gamma function equals 1 by gamma of s equals 1 by s multiplied by e to the negative Euler measure-only constant multiplied by s and multiplied by the product from I equals 1 to the infinity of 1 plus s by I to the negative 1 multiplied by e to the power of s by I. So how did this came from? In the last video, we proved that the gamma function equals the limit as n approaches infinity into the s by s product from I equals 1 to the n I s plus I. Let's divide this by I. So gamma of s equals the limit as n approaches to infinity and by to the power of s by s product and I equals 1 1 1 plus s by I, which equals the limit as n approach to infinity into the power of s by s, the product from 1 to the n of 1 plus s by I, the negative 1. We did the first one, so we're getting closer. Now let's see this n to the power of s. N to the power of s equals e to the power of s log of n. So we can change that to e to the power of s log n equals the limit as n approach to infinity 1 by s e multiplied by s log n product as I equals 1 to the n 1 plus s by I minus 1. What can we do now? So there's e multiplied by 1 there. So 1 e to the power of 0 equals 1. So let's just put it for fun. We didn't change anything, just for fun. 1 by s e to the 0 e s log n. In the Euler representation, we notice that there is a minus Euler measure-only. So what is the Euler measure-only constant? It's equals to exactly the limit as n approaches infinity, the sum as I equals 1 to the n 1 by I minus log n. We have log n, but we don't have this sum. So how do we have this sum? Um, and we have s. How do we get rid of s? Simply e to the 0. 0 equals so we can change the 0 into this two beautiful sums. So gamma of s equals the limit as n approach to infinity 1 by s e to the power of the sum as n equals as I equals 1 to the n s by I minus the sum from I equals 1 to the n s by I multiplied by e to s log n, which is plus s log n. We're getting closer. So how do we change that into the Euler-Mascheroni constant? Simply, let's take those. No, let's take this. No. Minus the sum as I equals 1 to the infinity s by I plus log s log n. How do we change that into the Euler-Mascheroni constant? Let's say this is equals minus the sum as I equals 1 to the infinity s by I minus s log n. Now we can factor this s as we factor this negative sign. So minus s, the sum as I equals 1 to infinity 1 by I minus log of n, which is minus s multiplied by the Euler-Mascheroni constant we simply found it. So we can change that into so gamma of s equals the limit as n approach to infinity 1 by s e of e and as I equals 1 to the n s by I minus Mascheroni constant multiplied by s, the gamma of as I equals 1 to the n 1 plus s by I minus 1. So let's separate those. We can realize that if we separate it, it will be e, let's just write it, equals the limit as n approach to infinity 1 by s e to the power of Mascheroni constant s e, the sum as I equals 1 to the n s by I, the product from 1 to the n 1 plus s by I minus 1. Let's see this. E to the sum. The sum is 1 plus 1, and you know that. So this will tell us that this will equals e by s plus s to the power of 2 plus s by 3, sorry, and so go, which is e by s multiplied by e by to the power of s by 2 multiplied by e to the power of s by 3, which is a product. So this the sum of a power is a product of a number. So you know what I mean. So this is simply a product, but without a sum. So we can remove the sum and move this into the product. Nothing has changed. 1 by s e negative Euler s, the product as I equals 1 to the n 1 plus s by I multiplied by e of s by I. So this is a constant, so gamma of s equals 1 by s e to the negative Euler s, the product from infinity I equals 1 plus s by I e to the power of s by I, and this is the Euler representation of the gamma function. Thank you guys for watching, and I hope you enjoyed it.